Friends, today I am now going to discuss Laurent series expansion. Laurent series expansion. So let's discuss about this topic. It's very much important topic for entering into the singularity portion of a complex function. So before discussing the singularity of a complex function, we should have a discussion on the Laurent series expansion. So let's start the discussion. What is Laurent series? Actually, whenever we are talking about fz, a function, a complex function fz. If fz is analytic in any annular region, write this point. If fz is analytic in any annular region with the center at z equals a, suppose that center is at z equals, suppose any point a, suppose it is z equals a is a center, okay, and the center is between what? The center is between the radius r1 and r2. As they are said to be analytic, then there will be two radius, one inner radius, another is outer radius. So we can first draw the picture to depict the annular region. First draw this a circle, okay. Annular region, we are drawing annular region. Change the pen color. Oh, I am taking again blue. Now let's draw another circle, okay. Inner circle, first outer circle, second inner circle, okay. Now draw this radius. Here it is radius r1, here it is radius r2, okay. Here it is c1, here it is c2, two close contour, and the annular region, the region where fz is analytic, that is, do the shadow of this portion, okay. So fz is analytic, that means what? We are discussing about a region where fz is analytic. Fz is analytic where? Fz is analytic in an annular region. Annular region means what? Where the center is at z equals a. Here the center, suppose this point is O point is center, and center is at z equals a, and it is between the radius r1 and r2, okay. So then fz can be expanded in such a way that we can expand fz in such a way that fz equals summation over n equals 0 to infinity n z minus a whole to the power n plus summation over n equals, now it will be summation over n equals 1 to infinity. Yeah, here it is n equals 0 to infinity, now it will be n equals 1 to infinity bn by z minus a to the power n. Let me write clearly so that you will understand. So this is a Laurent series, and here an into z minus a whole to the power n, and here this part bn by z minus a whole to the power n, this is called as principal part. Yeah, this is means negative power portion. This is called as principal part, okay. And what is this an and bn? An and bn can be written as an and bn. First write it. This is Laurent series expansion of Laurent series expansion of f of z. F of z can be expanded as summation over n equals 0 to infinite an z minus a whole to the power n, positive power of z minus a. A is the center of that function fz of that annular region, in the annular region where z equals a is the center, and here it is the plus summation over n equals 1 to infinite bn by z minus a whole to the power n. This is the principal part. Now what is this an and bn? The expression of an and bn will be n equals, we can write 1 by 2 pi iota integration closed loop contour C1 f of z z minus 1 z minus a whole to the power n plus 1 dz. Okay, and bn can be written as 1 by 2 pi iota integration C2 fz z minus a, okay, z minus a whole to the power minus n plus 1 dz. So this is a little bit theory about Lorentz expansion. So let's do some numericals. Let's do some problem.